Bismillahir Rahmanir Rahim. Distance vector routing. In distance vector routing, we are using the same concept of least cost routing that we saw in the previous video. In this case, how does distance vector routing go about doing it? To quickly introduce to you what the distance vector is, this is the least cost tree that we saw from the previous video. We have A as the root and we have the least cost to every other node from A. In distance vector, you take this information of the tree and you convert it into a vector. So you have A and you have the distance from A to A, 0, A to B, 2, A to C, 7, and so on and so forth. And in distance vector, every node takes care of creating this vector. So every node in the network will create a distance vector. So how does this take place? In the first step, right at the beginning, what every node does is it will consider the distance to its immediate neighbors only, right? So in this case, if you see A's distance vector, A to A is 0, A to B is 2. Now because C is not A's neighbor, A has inserted an infinity in its place. A to D, D being a direct neighbor of A, is 3, and the rest are all infinity. Similarly, we have the distance vector for B. B to A is 2, B to B is 0, B to C is 5, B to E is 4, and the rest are all infinity. So this is the first step. Every node makes its own initial vector by including information about its neighbors. In the next step, neighbors exchange this information with each other. When does this exchange take place? It takes place at two different times. One, when there is no change in the network, you could have it taking place every given time, specific time. For example, every 2 minutes, or every 3 minutes, every 5 minutes, every 30 seconds, okay? It is set by the network, and if there's no change taking place before this time, then the minimum is this time, every 2 minutes or every 30 seconds. However, if a node experiences something, a change in its vector, it will immediately inform its neighbors about this change, and it will not wait for that duration to finish. So if the duration is 2 minutes, if the default duration of exchanging information is 2 minutes, but if B experiences a change in its distance vector after 1 minute, it will immediately inform its neighbors about that change after 1 minute, and it will not wait for 2 minutes. Now looking at how this exchange of information takes place between the nodes. So we have A has now sent its vector to B. Okay? A has sent its vector to B. And now let's see how B gets updated. So this is the old B's vector, and this is A's vector. This will be the new vector. So in this case, we are placing the information that we already have as it is. Now, because this is the information about the direct neighbors, and this will not change. Okay? Now let's see here. Is there something that we could benefit from? Yes, it's D. We have a new entry for D, and for A it is 3. From A to D it is 3. But can we put 3 in here? No, because this is the distance from A to D and not from B to D. From B to D, we will have to go from B to A to D, right? This is the route we will have to take. And we know that from B to A, it is 2. So this is why we take the 3 from A to D and we add 2 to it. So the final value that goes now inside B is 5. So this is how we have updated the vector for B. Now let's say E also sends its values, its vector over. So now this will be the existing vector. And we have, again, same thing. Take the existing values and place them in the vector for new B. Is there anything new we have in here? Yes, we do. We have F, which is 2. And what is the distance from B to E? The cost is 4. Okay? The cost is 4. So we now add 4 plus 2, which is 6. So the cost from B to F via E is 6. So in this way, all the routers, they will keep on exchanging the information. Now what happens at this stage? Because B now has got a new value in it, some new information, it will go off and exchange this with A, with all its neighbors, with A and with C. So in this way, these devices will also update their own vectors with the least cost. So this is how distance vector routing works. The next one we see is link state routing.